Hi, everybody. This is the third lecture for Module 9. We're going to finish up with poliovirus, talking about what treatments are available and prevention strategies. And then we'll also talk briefly about some other enteroviruses. So I'm going to go ahead and pull up my PowerPoint. We'll go ahead and walk through this. So we're going to talk about why prevention is so important for the poliovirus. As you can remember from the video before this, you know that it can cause this paralytic disease and that it can also cause a post-poliomyelitis syndrome. So prevention is going to be one of those key things. We'll talk about the two main vaccines that are currently available worldwide for polio and the advantages and kind of disadvantages of each. We'll talk about what the result was of vaccination for the number of polio cases that we saw in the United States and how effective that was. And we'll also talk about the idea of eradication, how close we are to actually getting rid of poliovirus in the world, and some of the obstacles we face. Lastly, we'll talk about a couple of other enteroviruses that cause human disease. So we were talking about the pathogenesis of poliovirus, and I want to kind of talk about the way that we thought about treating it. So in the 1930s, we had what were called drinker respirators or iron lungs. So if somebody had paralytic polio that affected their respiratory system, they ended up spending time, sometimes their entire life, in iron lungs. In the 1940s, there was a woman, Sister Elizabeth Kenny, who started to show that physical therapy, rather than keeping people immobilized, helped those muscles. So in that case, it helped those muscles from losing kind of their strength while they were going through this infection. She also encouraged hot packs and hot baths to keep that circulation going in those muscles that were affected. Currently, though, we still do not have a cure for polio. So if you were to come down with polio, basically the best that we can do is supportive care, whatever it takes to kind of keep you moving, including physical therapy. And if you were unlucky enough to have it affect your lungs, we would likely put you on a respirator. There are no antivirals that are currently available to treat polio. So there isn't some medicine that we could give you that would actually slow or stop the infection. Prevention is the number one way that we can actually deal with this. And as we've talked about numerous times, one of the best ways to prevent viral infection is through vaccines. So the first vaccine that was produced was an inactivated polio vaccine. Remember, an inactivated polio vaccine is a vaccine that can't cause the infection. It is one that is basically, if it was a bacteria, it would be dead, but because viruses aren't alive, we call them inactivated. And this was developed by Dr. Jonas Salk. He grew polioviruses in monkey kidney cells for many, many generations, and then he inactivated them with formalin. In 1953, what they saw in the preliminary trials was that it worked well for children and adolescent volunteers, and so then they started mass vaccination trials in the 1950s. There was kind of a setback, however, it was quickly resolved. The manufacturer that was making Salk's vaccine produced a vaccine, some of it that was not adequately inactivated, which meant that some of it could actually cause polio. And so what they saw was 260 cases of vaccine-related polio. Basically, it gave polio to some of these people. The lucky thing was there were no deaths from this. And at the time, the public confidence for the vaccine stayed high, which is interesting when you think about kind of the times we live in now. And a lot of it had to do with the fact that many people saw the effects of a polio infection, and they wanted to take that chance of having a vaccine that would protect them rather than getting the disease. With the problem with the Cutter manufacturer, what we saw is that led to new requirements for safety testing, and also a surveillance unit that was created at the CDC to monitor kind of the spread of disease that could happen with vaccines. So Salk's vaccine, though, was the one that was considered the IPV or inactivated poliovirus. There was then a live attenuated poliovirus vaccine. And remember, live attenuated means that there's something about it that it shouldn't cause disease in the person, but it has the ability to basically replicate and it can actually spread. There is fear with that, though, in the idea that could it mutate and cause, become pathogenic and cause disease in humans. So in this particular case, what we saw was that they had a live weakened form of the infectious agent. The idea was that this would produce a much longer lasting immunity and less of a need for booster shots. The major concern, as I said, though, was how stable is that poliovirus vaccine strain, and could it revert back to where it would cause problems in humans? So this was created by Sabin, a researcher called Sabin. They did large field trials in Russia that showed that there was a lot of confidence that it was safe. And so at that time, the oral polio vaccine was approved in the United States in 1960. Within 10 years then, because the other one was in the 1950s, we had two vaccines that were available against poliovirus. We had that first one, the inactivated poliovirus that was injected, that was produced by Salk. And then we had the oral poliovirus. This was one that you took orally, that was a live attenuated vaccine. And this was designed by Sabin. Sabin's vaccine also had a benefit of that it included 3 different serotypes, so 3 different types of the poliovirus. So it had broader protection. So I did want to talk about what this meant for the US and the cases of poliovirus before and after vaccination. So you can see over on the left-hand side on the y-axis, we have the cases per 100,000. And then across the x-axis, we have the years, and we have 2 lines basically showing here. We have the estimated and reported kind of cases. So the estimated is actually up at the top, the reported were the blue. And what we saw is that we saw this big spike in the late 1940s and another huge spike in the early 1950s, late 1940s, early 1950s. And then we had the introduction of the inactivated vaccine. You can see that then we had this drop greatly. And then at the introduction of the oral vaccine, we had it go to where we saw basically no poliovirus in the United States, kind of in the early 1970s. And I'll talk about the idea of, we were hoping to do a worldwide eradication and why we've run into some obstacles with that. But you can see just by looking at the estimated and reported cases, how effective that vaccine was. So at this point, the CDC's current recommendation is to do the inactivated poliovirus vaccine, even though that has the need for multiple boosters, primarily because there are risks with the OPV, with that reverting back to a pathogenic form. So in the United States, we really just do the inactivated poliovirus, but this means you need to have multiple doses of it. So usually the first dose is given at 2 months, then a second at 4 months, then one in between 6 and 18 months, and then the last booster is given between 4 and 6 years. And that seems to be working very well. So it was one of those viruses that epidemiologists thought we could actually eradicate, meaning get it so that it no longer exists in the world. In 1988, the World Health Organization had a goal to have it eradicated by the year 2000. And there's a lot of reasons why this was one that we thought we could actually eradicate. For example, we have 2 vaccines that are now available, both the live attenuated and the inactivated. There's no animal reservoir, meaning that there's no natural animal that we find it, that it would be, that it could actually hang out in and come back and infect humans. And there's only 3 serotypes of the wild type viruses, and they're all fairly genetically stable, meaning they're not mutating at a high rate. One of the nice things too is that OPV, the oral polio vaccine, is pretty inexpensive, and it's easy to administer in mass vaccination campaigns because it's not a shot. You don't need a syringe. It's just an oral vaccine. But we didn't reach that, and I'll talk about some of the reasons why. So there's some obstacles that we've run into with eradication. The first is that it's very contagious, right? It spreads in that oral to fecal route very easily. It's the in addition, it's often people are asymptomatic when they're spreading it, so that makes it difficult. The inactivated poliovirus is not very efficient in stopping the spread of the virus. It can prevent the person from getting it, but it's not great at them not being able to spread the virus. The use of that OPV, or the oral polio vaccine, in tropical countries has been problematic. Remember, I talked about the fact that live attenuated generally has to be kept cold. It's hard to do that in places that don't have the infrastructure to keep that vaccine cold. And then I'll talk about this in just a minute when we get to a map. There's tensions in many countries regarding mass vaccination requirements, meaning that they don't trust the World Health Organization or those coming to do it in some countries. And I'll talk about specifically why polio has this as a bigger obstacle than others. And lastly, the verification of success is really difficult because so many people are asymptomatic and we only see 1 in 100 that are actually infected will get paralysis. It's often hard to know whether or not we've actually eradicated it or we just have a large population that is asymptomatic. So as we look at it, this is where we see polio pockets worldwide. And where we see the vaccines. So the vaccines are in blue are the ones that require the IPV only. Remember, that's the inactivated. The purple is the oral vaccination, the oral poliovirus only. And then we have a few countries that do both of them. But I was talking about the fact that we have a couple of countries that still have pockets of polio. Nigeria is one of those where it's considered endemic, and then Afghanistan and Pakistan. And I do want to briefly talk about why we see it still in Pakistan and Afghanistan. So you may not know, but during the time when Osama bin Laden was being searched for, there was a belief that he was in Pakistan in this compound where it ended up that he actually was. And in order to confirm that he was there before the United States sent in a team to kill him, they wanted to ensure that he really was on this compound. And so the way that they did this was they pretended to be vaccine, basically give vaccine to the young children on this compound. And when they did it, they took a blood sample of the children to see if they were, to compare it to DNA to Osama bin Laden to confirm that he was there. As you can imagine, there isn't a lot of trust now in Pakistan and Afghanistan that these vaccination programs are on the up and up if they use this in order to get blood from one of the children. So kind of an interesting fact when we think about those polio infected countries and how hard it is to then get in and get those vaccines to people. I will mention too that in the United States, we have had some polio outbreaks in upstate New York. It was somebody who was unvaccinated and likely caught it from traveling to a country that used the live attenuated vaccine and was actually infected because that person was shedding basically some of that from the live attenuated. But we know that the numbers of people who are being vaccinated for it is dropping in the US, and we could see it make a comeback. With that, I just want to finish up with some other enteroviruses or non-polioviruses that fall into this category. There are the Coxsackie viruses, which cause myocarditis or inflammation of the heart muscle, and also dilated cardiomyopathy, which causes damage to the heart. And so there's been a lot of research that's looked at enteroviruses as having an influence on this. So myocarditis, as I said, is the inflammation or degeneration of that muscle tissue of the heart. Dilated cardiomyopathy is disease of the heart muscle. And what happens is it causes it to become enlarged. And when it does, it doesn't pump blood as effectively. Often what we see is that this can lead to pretty high mortality rates, up to 50% mortality rates within 2 years for that dilated cardiomyopathy. Some of the other ones that we see are rhinoviruses that are triggering asthma. So respiratory illnesses account for almost 20% of all enterovirus-associated infectious diseases. And the rhinoviruses, which are the ones that cause the common cold, they've changed to belong to the enterovirus because we see that there is this new group of them that can cause asthma attacks in children. And what we see is that rhinovirus restricts replication, is restricted to replication in the cells of the respiratory tract, and it will cause kind of exacerbation of asthma in children. With that, we have our checking in. You can go ahead and pause this if you'd like and answer the questions, and then we'll walk through these. So for the checking in, are there any antivirals that are effective against the poliovirus? No, there aren't any antivirals that can treat poliovirus. What are the two types of vaccines currently used to prevent polio? The first is the IPV, which is the inactivated polio vaccine that is injected. The second is the OPV, which is the oral polio vaccine, which is a live attenuated vaccine that is ingested. What are at least two obstacles of eradicating polio? The first is this fear of worldwide vaccination, primarily because of cultural or things that have happened in that country that they don't want to. We also have issues with being able to do the oral polio vaccine in tropical countries. We also see that the IPV is not very good at stopping the spread of it. And lastly, it's hard to verify that we've actually eradicated it, since so many people would be asymptomatic with that infection. The last question is, what enterovirus group can cause asthma? We see that as the rhinoviruses. Hopefully that was helpful. If you have any questions, don't hesitate to contact me. Thanks.